Hi everyone, and welcome back to Spaced Out. I thought today we could talk about something I find really interesting, what I call the rhythm of the cosmos, basically resonance in the cosmos. So lately I've been really fascinated with how planetary systems form because there are just so many mechanisms in this process that we don't fully understand. Now, one of the fascinating truths we've discovered is that planetary systems don't just form in these seemingly random configurations like we see them today. In many cases, in fact, most of the cases, they come and emerge and are born in these elegant patterns called mean motion resonances. This is when the orbital periods of two planets become locked into near-perfect integer ratios because of their repeated gravitational interactions with one another. So let's talk about an example. Say Earth and Mars are in a 3:2 mean motion resonance. This means for every 3 orbits Earth completes, Mars completes almost exactly 2, so that they line up over and over again according to this pattern. Now, this happens because the planets repeatedly tug on one another at the same points in their orbits, creating a repeated rhythm. Now, these patterns were so mathematically beautiful that early astronomers believed that they just couldn't be accidental. In fact, Kepler and Pythagoras believed that the solar system arose from intelligent design, and that the most intelligent design must be this resonance. In fact, Kepler called this the harmony of the worlds, like some kind of cosmic music. But if we fast forward to our discoveries now, we see that while resonances do exist across planetary systems, they're not as common as they are at birth. While many young planetary systems appear to form in these resonant configurations, only about 15% of systems around the age of our own solar system are in resonance today. So while many systems start in these full resonant chains, they don't end that way. To understand this, we need to learn about whether resonance is protective or destructive. And we can start by examining resonant chains. So resonant chains are just planetary systems where 3 or more planets are locked into resonance with one another, like links in a gravitational chain. We even see a small example of this in our own solar system with 3 of Jupiter's moons, Io, Europa, and Ganymede. So for every 2 orbits of Io, Europa completes almost exactly 1. And similarly, for every 2 orbits of Europa, Ganymede completes almost exactly 1. Even more extreme than this is the TRAPPIST-1 system, where all 7 of its planets participate in a complex resonant chain. But if resonances seem to be so mathematically perfect, how do they disappear? To understand that, astronomers look at something called the resonant angle. So the resonant angle is just a mathematical representation of the orbital positions and orientations that tracks how 2 orbits align over time. And this resonant angle can behave in 2 very different ways when it's near resonance: circulation and libration. Circulation is like a pendulum that's just spinning all the way around in a circle, or like a ball on a string as you twirl it around your head. This resonant angle is able to sweep through the full circle, right? The full 0 to 360 degrees, and it never settles in one spot. This means that if 2 planets are in resonance with one another and they're circulating, their orbits can take on different positions every single time they line up. So the gravitational interactions between the planets when they line up don't repeat cleanly. Instead of canceling out over time, they can build on one another, potentially destabilizing the system and increasing the chance that they get so close that they collide. Now, libration is like a classical pendulum that just swings back and forth around equilibrium. The resonant angle in this case oscillates within some fixed range, and it can only have certain values. So the orbits of 2 planets are pretty much the same every single time they line up. Therefore, as you can imagine, the alignments between the planets repeat in a controlled way that protects the planets from ever getting too close. That's what makes resonance stable. So by these definitions, we've come to understand that resonance is really only protective when the angle is librating. If it begins to circulate instead, this protection will weaken. Now, we see the importance of this distinction of libration versus circulation in our own solar system too, between Neptune and Pluto, if you still consider Pluto a part of our solar system. Neptune and Pluto's orbits actually cross one another, which sounds really destructive, especially so close to Earth. However, because they're in a librating resonance, they're protected. Every time Pluto crosses Neptune's orbit, Neptune is far away, and when Neptune is nearby, Pluto is nowhere close. So despite their crossing orbits, they never actually collide. Meanwhile, in the asteroid belt, we see these strange empty regions called Kirkwood gaps, which represent regions in which objects in those areas are in a circulating resonance with Jupiter. This means that any asteroid that lands in one of these locations has a destabilized orbit and it's ejected, which is why we don't see any asteroids living there. So we've come to see that over long timescales, the circulation sounds pretty dangerous. It can push planetary systems into more chaotic phases. Now, why does this matter? How can we use this to learn something new? Say we have a planetary system that breaks out of resonance, and say the outer part of the chain that's further out in the disk, far away from the star, say that part breaks out of resonance. Material can get scattered into the inner parts of the chain, like where our own Earth is. That could trigger giant impact events, like the kind that formed the major craters or even killed the dinosaurs. But if you think about it, it could also work in a very beneficial way. Those same instabilities might deliver volatiles like water or ice from the outer icy, colder part of the solar system to the inner, warmer, rocky planets, potentially delivering the ingredients necessary for life and maybe creating the start of aliens. So these beautiful resonant chains might be absolutely detrimental to habitability or incredibly essential to it. Thank you for listening, and I'll talk to you next time.